Okay, so we have here a circuit, an RL circuit, which we are asked to find VR and IL for all t. The initial value of V equals 4 plus AT of t. First, we need to recall our calculus for a unit step test, which is U of t equals 0 and 1 when t is less than 0 and t is greater than 0. So first we need to find our VR and IL for our first time interval, which is t is less than 0. So we're going to transform our circuit like this. So initially we have at t less than 0, our voltage here will be 4 volts. Why? Because our initial voltage is 4 plus AT of t, and when t is less than 0, this will be 0. So V equals 4. So 4 volts. As you have noticed, I have shorted our inductor here because in our first interval, we're just going to need our force response, and we can't find any natural response at our first interval. So in order to find VR and IL, first we just used the voltage division theorem for VR. But first we need to combine these parallel resistors, which is 4 ohms and 4 ohms. So we have our new R for here. Our new R here should be equal to 4 times 4 over 4 plus 4, which is approximately equal to 2 ohms. So we have 2 ohms. So 2 ohms and 2 ohms, 4 volts. So to get the voltage VR, after adding this parallel resistor, remember that this resistor 2 ohms has the same voltage for our 4 ohms in and 4 ohms here. Why? Because they're in a parallel position. So even though we combine them, they still produce the same voltage as when they were separated in a parallel form. So to get the voltage VR, it is only equal to voltage VR is equal to 4 times the voltage across in this part, 2 ohms, we're getting the 2 ohms over our total resistance in our circuit, which is 2 ohms plus 2 ohms, which is approximately equal to 2 volts. And IL is just equal to VR over the amount of resistor here, which is resistance here, which is 4 ohms. So that is equal to that is equal to 2 volts over 4 ohms equals 1/2 ampere. So now we're going to find our equivalent circuit for t greater than 0. So at t greater than 0, we have a circuit like this. Four ohms, 4 ohms, and positive negative VR and IL. So our V now here will be V would be 4 plus 8 times 1 is 12 volts. So 12 volts. Now our IL will be having a equation of IL of t will be having an equation of ILF plus ILN. So this ILN would be the equivalent IL for an RC for a source free RL circuit, which is equivalent to A times E negative T raised to R time constant. So RL of IL for all T would be equal to ILF plus A E negative T over R time constant. First, we need to get the value of our ILF. In order to do that, we just need to short our inductor here. So it will look like this. 4 ohms, 2 ohms, and 12 volts. To get the IL, I'm just going to do the same process I did here. So first we need to get the voltage at VR. This is the same process, only that we have a voltage source of 12 instead of 4. So 12 times 2 ohms over 2 plus 2, which is approximately equal to 6 volts. So our IL here, or ILF, would be equal to 6 volts over 4 ohms, which is 3/2 ampere. So now we need to get the value of our VR and IL at natural response. So ILF, which is 3/2 ampere, and VRF, which is 6 volts. So in order to get ILN and VRN, first we need to short our voltage, or to short our voltage source to get a source free RL circuit. So we have here a circuit that looks like this. Sorry for the drawing. Positive, negative VR and IL. So first we need to get the value of our time constant, which is equal to L over R, RT rather. So to get RT, we just need to add this resistance here, RT, which is 2 parallel 4 plus 4 ohms here, which is equal to 2 times 4 over 2 plus 4 plus 4, which is approximately equal to 3 ohms. So which is approximately equal to 16 over 3 ohms. So our time constant, L over R, equals 2 over 16 over 3, is approximately equal to 3 over 8. So our ILN is AE raised to negative T over 3 over 8 is equal to AE negative T 8 over 3. So our IL of T will be now equal to 3/2 plus AE negative 8 T over 3. To get the value of A, recall that in our initial solving, we have IL of 0 negative equals 1/2. Remember that IL of 0 equals IL of 0 negative and IL of 0 positive. So at IL of 0, we have 3/2 plus A E raised to negative 8 times 0 over 3. We have 1/2 equals 3/2 plus a. So we have a equals -1. So our IL now, ILN, oh sorry, IL of t would be equal to 3/2 minus e raised to -8t over 3. And VR is just equal to 4 times IL of t, which is equal to 4 times 3/2 minus e -8t over 3, which is equal to 6 minus 4e -8t over 3. So our IL now for all t would be equal to 3/2 when t is less than 0, and 3/2 minus 8e t over 3 when t is greater than 0. And VR for all t would be equal to 2 when t is less than 0, and 6 minus 4e 80 over 3 when t is greater than 0. So that's it. Thank you for watching.